Here are the Mod 12 Part 2 notes. This is page 3. We've got 2 examples here, one with 2 parts. So example 3, Texas Workforce Commission reported that the state unemployment rate in March 2007 was 4.3%. We want to describe the sampling distribution of the sample proportions for unemployment with a sample of 250 people. Again, it asks us to verify the normal distribution, so we're going to do that first. And then we're going to find the mean of our sample proportions and the standard deviation for our sample proportions. So we know our n is 250. Our population proportion is that 4.3%, 0.043. First thing we're going to do is verify a normal distribution. Verify. I need to check to make sure that n times p times 1 minus p is greater than or equal to 10. So I'm going to plug in my values. With that subtraction there, I get 10.2877, and I really don't need to be that precise. The 10.3 would have been enough because that is greater than or equal to 10. So this satisfies the central limit theorem. Next thing we want to find is our mean of our sample proportions. You said p hat is going to be our population proportion, which is 0.043. Last thing we need to find is the standard deviation. Here's our formula for standard deviation. So I have the square root of 0.043 times 0.957 divided by our sample size of 250, and we get 0.0128. So there are our basics. Now we want example 4 to compute those probabilities. So the Texas Workforce Commission reported that the state unemployment rate in March was 4.3%. We want the probability that a sample of 250 people will have an unemployment rate of at least 8%. So back to our distribution again. We've said that this satisfies the central limit theorem. So we know our sampling distribution is going to look like this. Okay. I have got a standard deviation of 0.0128 when a sample is 250 people. So 0.056. 0.069. 0.082. At least 8%. So we are looking for this little bit. So we've already verified that this satisfies the central limit theorem. I want the probability that my sample proportion is greater than 0.8. I'm going to the right, so this is a 1 minus. Again, it's a normal distribution. We're using norm.dist. We're checking for 0.08. My mean is 0.043. My standard deviation, 0.0128. Cumulative, so we cram that one in there on the end. See if I can move my mess over. Clean this up a little. I've got the probability that my sample proportion is greater than 8% of 0.0019. So 0.19%. Find the 99th percentile of a sample proportions for a sample size of 250. So here, I want that sample proportion norm dot inverse means I'm taking in that probability when my mean is 0.043. That's the mean of all the sample proportions, and my standard deviation is 0.0128. So a little note down here, norm dot inverse. It's the probability, mean, and then standard deviation. So the proportion that cuts off 99% is at the 99th percentile. That means 99% of the samples. It's going to have a value below 7.28%.